Всем привет! Как здорово, что вы все-таки пришли на этот доклад. Это, по-моему, уже третий доклад за сегодня, где так или иначе будет упоминаться Terraform. И как минимум, наверное, 10-й доклад, где упоминается AWS. Поэтому это значит, что вам все-таки интересны эти темы, или вы просто не знаете, куда пойти. В общем, сами решайте. Если вам надоест или вам станет скучно, то вы можете фолловить меня в Твиттере, потому что я там говорю иногда чуть-чуть про другие вещи. Но там никакой политики нет, хотя могла бы быть. В общем, тема доклада такая. Я до последнего сомневался, на каком языке рассказывать. Sorry, why I'm speaking Russian? Oh my God. Yeah, right. In fact, this talk should be in English, so I have to switch in English. Oh, sorry. Okay, the title of the talk, as you can read, is Design, Draw, and Deploy Infrastructure from Inception to Production. I have created these slides in English, and I was really hesitant to translate it to Russian. And then they told me that it's okay if I talk in English. So yeah, thanks again. Okay, I have completely reworked slides and the idea of this talk approximately a couple hours ago. So hopefully you will be able to follow what I'm talking about. So let's start with idea. Okay, you want to work on something and you don't know what you are going to work with. Like you want to develop one project, you have no clue how to get started with it. So you have an idea. Okay, what to do next, right? Normally, that's typical. My clicker never works on talks. So I will stay here. So what is next, right? You have to capture some thoughts and you have to talk to other people. You have to figure out what kind of requirements do you have, what exactly you're going to do, what kind of product idea, people, audience, and so on. So you have to collect and you have to develop different connections in your head in order to figure out what is it. And then you have to start creating it, right? So normally, people, including myself, I usually start with creation just because it's fun, because I can see something visible, I can see something going on, and I'm really excited about keeping my hands dirty and do something. In fact, this is not what studies recommend, so you should do things methodologically. Fine, okay. So if you would have whiteboard like these people on this image, you would go to whiteboard and you would probably visualize and think about what exactly you're going to do. So what you normally do is that you try to solve the easiest question first. Like, hey, we're going to use this public cloud provider or that one. I've heard that GCP is better in that one because it's Kubernetes. No, we have to use PHP, but why not Golang? And so on. Come on, there is serverless as well, so we have to go serverless. This is a type of questions which we are usually willing to answer and willing to discuss as early as possible, though it doesn't make sense. So let's talk about infrastructure. Okay, infrastructure is everything what is needed to support the computing requirements of an application, which typically means that you have to have some network, some storage, some compute requirements, and so on. So all of this is called infrastructure. Who knows what is DDD, right? Who knows what is DDD? Can you raise your hand? Okay, yeah, right. So what is it? No. It's design, draw, and deploy. Okay, and my name is Anton Babenko, and for last many years, I've been actively doing different talks, and I actively contribute to open source projects related to Terraform and AWS. And I'm actually AWS community hero. As I was told yesterday, I'm the only one who speaks Russian and community hero. No, this doesn't work. No, it works again. Okay. So I do a lot of open source projects. And if you've been using Terraform on AWS, there is a pretty big chance that you used or looked, or maybe you even were inspired by some of projects which I developed. If you've been using Terraform and you pay attention to quality or documentation or validation of the code, you probably saw a tool like pre-commit Terraform, which allows to run some validation or update documentation of your Terraform code. I also try to share knowledge and information which I got from different meetups and conferences like this one with a much bigger audience. So I have published terraformbestpractices.com and Terra Grant reference architecture. And also, if you are using GitHub or Twitter, or even LinkedIn and you're not hiring people, please connect and you will be able to follow what's going on in Terraform world because that's what I do full time. Who know what is this one? Who use Terraform AWS modules? Right, excellent. So actually, oh, that's cool. That's cool. Yeah, that's really cool. So you guys are actually one of this 7 million download is actually by you. That's pretty cool. So the reason why I mentioned this one is that early on I was a big fan of reusable everything. Libraries, something what can be shared across different projects. Even before I started with DevOps, I was working with web development. And one of my best projects where I worked on one feature and got paid by one customer in one building as freelancer. And then I had another customer where I was implementing exactly the same functionality, but I was paid again. So what I did is that I was paid twice. Functionality was very similar in both of these places, so it means that I have to implement it once. Typically, it was something related to user authentication or some sort of CRUD operations on databases, so it was very easy to copy-paste the same solution multiple times. So since that time, I was really big fan of reusable everything. Reusable infrastructure is natural transition for me. And 2017, I published Terraform AWS modules, which were official Terraform modules for people who want to spin up infrastructure on AWS, which means that if you are going to spin up a VPC or auto-scaling group or any other type of services, most likely you're not the only one who are going to do this. So that's why these modules exist, and lots of people are actually using them. They also show how to do things properly, some design patterns, and so on. So if you are working with AWS and still writing something yourself just by following documentation, I encourage you to check this out and use it. And you can just buy me a beer because it's cool. Thanks. Right, Terraform. Please raise your hand if you don't know what is Terraform. Okay, good. So because I don't have any slide explaining what is it, so that's good. The only thing which I want to highlight is that infrastructure as code makes DevOps possible. And the reason for that one is that we need to treat our infrastructure code as similar as possible as we do with the application code, which means that we always should be able to know what exactly has changed or why it was changed. And we should be able to put it in some sort of pipeline where we can validate infrastructure through some sort of pipeline, environment, staging, production, whatever. And this is really critical points. There are a bit more than these 3 points, which you can read on the link below, but I really like these 3 points because they're essential for everything what I'm going to talk next. So let's look into what our normal project looks like. As you remember, I started the talk when I put as some rough idea that, okay, I have an idea, I want to make this happen. So fine, then I figure out that, okay, I'm going to design my AWS infrastructure. So, well, it's not so easy. There are so many materials. That's why actually cloud architect role exists, right? Because people want to get paid for the fact that they be able to read this information and able to answer some tricky questions. So yes, they should know about what is well-architected framework, how to use different services, what are trade-offs of different architecture patterns, and so on. I really like to study all of these materials, and I probably read most of it because I was preparing for presentations and for talks. And I really recommend you, if you don't know what to do or you think that you already know something, just visit any of this and start from well-architected framework and see where it goes. It has lots of references, lots of links, and you will be able to improve your knowledge dramatically. Then when you figure out what exactly you're going to do, you have plenty of options. The first option which you can do is that you use whiteboard and you just go to whiteboard and you think like, hey, there is this service which I will connect to that service, everything will be fine. But as soon as there is a need, there is definitely a product by someone else. Right now you can see these products available. Plus, there is also something what you can run on your machine, which will produce similar drawings. I'm gonna to mention Cloudcraft, and I'm sure that most of you saw AWS infrastructure is created, and you probably saw them on some sort of presentations, talks. They are typically isometric projection where people can specify different things like components, properties of those components, some errors to point what's related to what, and so on. Okay, so we talked about extremely short amount of information about what to do with design of infrastructure, how to draw infrastructure. Well, let's say we figure out these two things pretty easy, right? Now, what to do with deploy? I mean, we are at conference which is called DelEx, which is delivery excellence or somewhere in between. So we should be able to focus on deploy. And this is where the most exciting part starts. So what should we do with deployment? Let's look into what kind of infrastructure exists at all. Like, think about this. There are 101 shades of infrastructure. If you are into binary, you will understand this joke. The first one is infrastructure as PowerPoint. Okay, it is typically called infrastructure 2010 final or fixed.ppt, and it's definitely obsolete since 2010 because many things changed, nobody touched it, or somebody touched it but didn't update it. It is also called ClickOps, where you open AWS console and click, and you have infrastructure, and then somebody dump it as PowerPoint. So yeah, it is existing. Another type of infrastructure is infrastructure as JSON or YAML files. Typically, AWS CloudFormation or Azure Resource Manager are good players in this field. Another type of it is infrastructure as configuration files. This is exactly where Terraform is. Well, you can think that this is a code. Not really. Infrastructure as structured key values configuration file. This is where TerraGrant is. And I will focus on this a little bit later, but think about key value as something what is key differentiator between Terraform and TerraGrant. It has a lot of other benefits, but just now think about structured key values. This is TerraGrant. And the last one in this shade of infrastructure is actually infrastructure as code, where AWS CDK as well as Pulumi are feeling pretty well, because people actually want to describe infrastructure as code. So definitely there are products where you can do this. Now let's think about requirements and preferences for our infrastructure. Well, we design something, we spend some efforts, and now we think about what kind of requirements for our best deployment tool we should have. Fine, infrastructure as code, definitely. We want to be able to make it reproducible, use proven technologies with big community, with following best practices. So we definitely want the best of the best, right? Who doesn't want best of the best? Yeah, okay, a couple of people, excellent. So what you should really care about? What's your opinion? Like you can think, okay, you have to pay attention whether it is declarative or imperative approach, and maybe push versus pull. No, that's all bad because my solution is 10 lines and your solution is 100 lines, so mine is better. I can actually write a test for that, but you cannot. That's kind of debatable. I can use programming language, but you have to stick to markup languages or configuration languages. So people often talk about these things as really critical and important stuff. And then we think like, no, DSL, which is domain-specific language, or maybe use object-oriented patterns or programming. And then we look into like, no, my tool of choice is extremely popular. I will definitely stick to it. So which one of these you think is actually really important, and which one you think is critical to take into account when you talk? Let's say you go to next stand-up and somebody will ask you like, hey, I've heard about CDK and we're using AWS. Should we use CDK? And another person say, no, we should use Terraform. And then somebody from Hacker News will come and say like, hey, I've read about Pulumi. So which one of these factors is actually important? Sorry? Testability. Wow, that's pretty unusual to hear. All of them is pretty close. I would say that simplicity and possibility to increase your speed and increase your features in fast manner is first important. Second one is, or actually all of them on the same level to my mind, but way to control and how much effort will you spend in order to make your infrastructure work is really critical. I mean, if it's 10 lines and you cover it with all tests, but only 2 developers understand what's going on because there is no documentation, it doesn't help really. So I think that simplicity is key here. That's why tools like CloudFormation doesn't feel so well when end users are asked. I mean, if you ask management, they may have their own opinion. But at the end of the day, developers will not tell you like, yeah, I fall in love with simplicity of CloudFormation, because these two things doesn't connect together. Simplicity does not equal to CloudFormation. Velocity, yeah, it is really cool that I change something here and then in short amount of time without too many checks, I can deploy this or I can run some next step. This is cool. Then I don't have to wait for many approvals. So think about these 3 factors as really important. And approximately 2 years ago, I was looking into Cloudcraft, where some of my customers visualize infrastructure, and then they came to me and say like, hey, now can you please make this happen because we want to use Terraform and we want to get this infrastructure described. So what has happened? Cloud Architect has already spent some time talking about infrastructure, connect all of this stuff together. It looks pretty cool. Even today at some talk, there were people, I think talk by Andrew, where he showed some infrastructure, and then DevOps engineer was asked to, hey, can you please make this happen? And I was asked this to do this thing for at least several times, and then I thought like, yeah, I like actually reusable things, so let's make a tool which allows us to get information from the visual diagram and get it into really working infrastructure as code. So this tool is called modules.tf, and yes, I have stickers if you want. And it is written in Python, it is open source, and it is actually in use by several types of people. And the purpose of this tool is that you should be able to get started with it. So you have Cloudcraft as a main component. Cloudcraft currently is the only implementation where I get this visual information from. I design it in a way that I can actually replace anything, to put anything instead of Cloudcraft. So it can be any structured data, like text file, JSON file, API calls, whatever can be used. And then I use already existing building blocks, Terraform AWS modules, and together with Terraform and TerraGrant, I orchestrate this thing and actually make it usable. I will show this, so you don't have to just trust me, because I will show this in action, okay? Good? Good, because now it's time for demo. I actually have no clue how much time left, but demo is important, so let's make it. Here is infrastructure which I visualized. Yes. So here you can see some elements. I can, of course, delete all of this like this and start from scratch, but without mouse, it's pretty hard for me to draw. So I can just navigate here and explain what's going on here. So I put some of components from the left side here, like elastic load balancer. And I put this elastic load balancer into region. And then I put security group around this elastic load balancer. Because as you know, elastic load balancer belongs to security group. And then external resource on top of this, I put VPC, where this VPC is, yeah, it has, you probably don't see different colors, but yeah, this color is actually different. And the purpose of this very simple infrastructure is that your cloud architect has already spent time talking about what kind of load balancer it is. He specified it to be classic. He can do something else as well, like application, for example. And then you can think about what kind of security group rules or ports should be open. So here he can specify some values. And when you see this infrastructure, I forgot one important person here, which is called user. Otherwise, it's hard to figure out how to get from user to load balancer, right? So we have to put this connection here. It's, again, not very important, but it just makes sense what user reach. So user reach load balancer, and then from load balancer, request will be sent to an auto-scaling group where T3 micro is used. And here we can specify what platform is it and what other things are here. Everything what I show here is available for free. I'm not talking about commercial features at all. You can just register here with Google account and it's free. Once you visualize all of this, as a cloud architect, you go to Jira and you say like, hey, done, I don't care about this anymore. Someone else has to do this, right? So you put it closed or assign it to your poor DevOps engineer, who then open this one and ask like, oh, come on, what is it? Like, what kind of properties I should be doing here? Like, oh, I don't know anything about these resources. But the solution here is that he click export, Terraform code export, and he got this diagram. After AWS Lambda function processes, you get this zip archive here. So now let me show what is actually inside of this zip archive. Because it would be absolutely a wrong thing if this infrastructure would be just a boilerplate, right? I mean, we all know this project where you download something, it's called boilerplate, and you look into it and you cannot use anything of it because it doesn't fit your project at all, not structure-wise, not content-wise. So you just look for this and think like, oh yeah, but it doesn't help me. In fact, this archive is generated extremely specific for your infrastructure based on what you described. So it contains correct values here, like region names, name of layers, which is auto-scaling group, and so on. So all of this text is designed, or it is templated to help you to get started. So if we look into the content of this folder, there are a few files here. The README MD is the one which I'm showing now, and inside of it, there is a folder called test small. So inside of that folder, you can see each of these layers or each of these components which you placed into the diagram. And this is exactly where most of work should have been happening because developer would just go to, let's see, developer would go here and then, oh, okay, it should be classic. So then he goes to the code and figure out how we create classic load balancer. And his options normally would be to go to registry.terraform.io, find for available code, figure out how to use it, and so on. Modules.tf is actually doing this for you. So if you look into ELB folder, you will see Terragrant HCL file. Terragrant HCL file contains all relevant information which you need to know in order to work with it. So here we see the source of it is Terraform AWS modules called ELB. And there we can see block of dependencies, like what exactly has to be created before load balancer can be created. Well, it is VPC and security group. Otherwise, it doesn't work. And inside of inputs block, we can see what kind of inputs we want to have. Here we already specify health checks, and we specify security group and subnets. Here you can see the cool part of Terragrant, which actually helps us to work with Terraform modules from kind of without knowing what is exactly inside of that module. So what we have, let's say, on subnet. So subnet value is going to be taken from VPC output public subnet. And configuration for VPC is declared here, config path .vpc. So if we look into VPC folder and we see the content, okay, we're using VPC module, and then we can see some values here. So what will happen is that now if we are going to work with this infrastructure, it's job of Terragrant to figure out which values should be coming from where. And as you can see, all of these values are not hard-coded. So subnet is not actually a fixed list of values, because by the time when we will execute this code, we don't know what kind of subnet ID we will get. So we cannot hard-code anything. And what we want to do is that we want to have configuration in a way which we can easily work with. There are very few things which you need to know when you work with Terragrant. One thing which is very important is that you don't see Terraform code at all. Okay, so there are no resources, no data sources, unless you really want to use them. And the point here is that when we use soft references like dependency, we delegate this job to Terragrant to orchestrate it. Let me show how it actually works, because you probably don't believe me that it works at all. Well, it worked. So if I go to test small and I write 3, something like this, yeah, it doesn't look so interesting, but still, you can see that we go to test small and then inside of EU West. So this is where we have configuration for our layers. We are not calling any Terraform file. We are letting Terragrant to do this for us. So what we have to do now, first we have to hope that my credentials didn't expire. But if we do this properly, we need to run something like apply all. Well, if we run Terragrant apply all from the EU West 1 folder, we can see that EU West 1 actually contains a lot of other folders. It contains this, all of layers. And that's exactly what we want. We don't want to go to a specific folder and run it, and then go to another folder and run it again, and so on. So we go to EU West, and we run apply all, and we say that, yeah, it makes sense. So we say yes. So while it's doing something, you can see that it's like first challenge is to follow output from Terragrant. It can be challenging. It's a lot of output. Most of this output doesn't make any sense to you, not to me, not to developers, not to really anyone. So what I did is that I did, what is it, alias, wow, it doesn't work, alias, no, which, right. So I wrote a function where I use my favorite sed to remove useless output. Because if I wouldn't have this function, I'm sure that most of you would be dizzy because of amount of output which it outputs on screen. It's still a lot of outputs and actually some errors, which is typical during demos, right? Yeah, so it is EU West 3. Oh, right. Yeah, it was bad choice from me. I made infrastructure in 2 different regions and it didn't work well. So let me just show another example which is very similar to this one, but with slightly better test 2. And here, test 2. Actually, it is very, very similar output, but without experimental feature, which apparently didn't work during live demo. But now it should be at least working better. Anyway, the outcome of this thing should be that a lot of resources created in AWS, and we have configuration inside of structured approach, and we can use tools to continue working with it. Terragrant is definitely one of those tools which you need to look into and pay very close attention when you are working with more than few machines or few environments. I really recommend to take a look on it. So while it's doing something for second attempt, which is hopefully going to succeed, it is creating a bunch of different resources. Output is still not usable, but at least just believe me that it's much better than by default, because said magic expression works brilliantly. So now it should take a little bit time. Yeah, actually it finished. So what we have now is that all of this infrastructure has been created for each of this layer. And we can just go to this one and see how things are configured here. If we look into, let's say, security groups, we see some security groups being created, and yeah, and many other resources like load balancer and S3 bucket. It has been created as well. So from demo part, this is pretty much it. I still have a couple slides which I want to go through. So what is actually the purpose of this approach? Is that the generated code which we have is definitely potentially ready to use Terraform configuration. Potentially is a key word here. A lot of information which you wanted to provide, like some metadata which you normally have, like, I don't know, key pair name or some security group specific things, it's pretty much impossible to visualize inside of visual diagrams. So that's why it says potentially. Potentially means that you still have to read through it, you still have to understand what is it, but your way to go deeper into this should be just step by step. So normally you will have something very much working from, as I showed just immediately, you will have something working. And yes, it is unfortunately best fit for bootstrapping. And bootstrapping is just initial process. There are some intention and some interesting challenges when it comes to how to integrate these three things together, like how to reflect changes in the code, how to reflect them into visual diagram. We are kind of discussing how to make this, but it's extremely hard. So right now I focus on making it really good for bootstrapping. And bootstrapping itself doesn't make sense if you're going to just look at it and delete most of it. Because modules.tf actually enforce standards. Standards in naming, in code structure, in sharing data or Terraform state files between different regions, between different accounts, and so on. So these standards are really important to follow early on. And please don't introduce your own standards until you tried 15 other standards which other people did. Otherwise, we'll have 16 standards. And enforcing Terraform best practices and, in general, segregation of duties between Terraform users and Terraform developers, or as Alexander told on his previous talk, also between product owner, is essential part of successful work and using Terraform as a team. You cannot use Terraform effectively if everyone have possibility to do everything. You have to enforce structure, naming, who has possibility to modify modules, who has to be able to use them, and so on. And yeah, there are also all kind of batteries included in terms of existing Terraform AWS modules are used, and pre-commit Terraform is used to automatically format and document code. So that's really built-in feature. And yeah, it is 100% free, open source, MIT license if you're into licensing. I honestly don't, because most of stuff which I do is open source anyway. So yeah, check out the source code and at least put GitHub star. I mean, maybe it will help. So yeah, I really want to know questions, and we have probably like 8-7 minutes left. Please follow me on these things. And Anton Babenko is my blog, where again I blog about what? Exactly, Terraform. So that's the only thing which I'm doing for the last many years, and thanks for listening. Any questions? Yeah. Yeah, what's...
So do you plan to support some in-house instances? Because, you know, in test automation, many teams build their own test infrastructure, and this infrastructure consists of many parts, and some of these parts are in cloud, in the AWS cloud, right? And some of these parts are in in-house instances. I'm talking about mobile farms, TVs, Xboxes, etc., right? And it will be pretty useful to have such solution just to draw cloud architecture, right? And draw in-house architecture, and then just to make them work together.
Yeah, I think it is really interesting kind of need to be able to expand it in all directions. The reason why I focus on AWS is actually because I had already these modules. If I wouldn't have these modules, but let's say if I would be working with GCP, most likely I would do the same for GCP. And now it is implemented in a pluggable way where you can actually override, let's say, icon with this ID equal this Terraform module. So you can make this yourself. You can say that if somebody put this icon into the diagram, then in your code, it should be translated into module how you, I don't know, manage your type of Terraform resource. So it's like, it's very soft, but I implemented extremely focused on AWS, and I'm not done there. It's a lot of work.
Thank you.
Thanks.
Well, first of all, I would like to say you thank you, great, for your presentation, for your contribution to the open source projects. And what features do you plan to provide in the nearest future in this project?
This project will, like most of time, which I'm going to spend during the beginning of March, are going to be used on validation. So when you visualize something, there are so many things which looks good but doesn't make any sense. Like S3 bucket does not belong to VPC, you know. But many people put errors and put connection. It doesn't make any sense for me to process. So what I'm going to focus on validation phase. Whatever you visualize, you can click export as Terraform code, and it will tell you like, hey, but did you mean to use this strange configuration, because it doesn't make sense. And this, on my like preliminary research, improve quality of infrastructure code significantly. A lot of people put so many strange things, which I don't even understand why. But when I ask them like, what did you mean? I say that, you know, you have to use just different things or different servers, different connections. This is one. And second one is that I want to focus on providing metadata on each resource, which means that when you put EC2 instance, I want you to be able to specify everything what module expect inside of visual diagram. This is very challenging part because of different types of input. It's not just string. You know, it's not like input field. It's actually a list of maps, of lists, and so on. So it's very hard to make it predictable. But I think I will finish it, at least from my part. Then it will be job of Cloudcraft guys to implement it. And again, everything what I showed is available for free, so you can just try it yourself, and you will see if there are bugs. Please report about them, because I receive alert message from CloudWatch and some other monitoring systems, but I really don't have enough information what you wanted to draw. I sometimes see some information like what kind of error is it, but sometimes this error is indexed out of range. Thank you very much. What does it mean? So yeah, there was a question from that side.
First one, thank you. So about the coverage, how many services do you cover in the solution? And the second part about one of the cons. So right now I'm interested in the security services posture that Amazon provide us, and we are locked in some cases because new services we are waiting for in the Terraform coverage, and we're waiting for them. How long we should wait if you use your solution after the Terraform describe the way of services description and how many time we will lock after that, then it will be opened in your solution.
I think it will take ages, honestly. No, the thing is that there are so many dependencies between, like AWS announce feature, AWS create feature, people request this feature on Terraform provider, people write some code on Terraform provider, we wait, and then it's merged, released. So all this train takes approximately 3 months easily, right, at least. Sometimes it takes half year, or yesterday we closed issue which was 2 years old. I was like, oh my God, I even forgot about it. But once it is implemented inside of Terraform, what I'm going to work with is just Terraform modules. If anyone from the community make module which implement this feature, there are few requirements which I have to enforce on these modules. Once this module exists, then I can say that when, let's say, you put this icon or this service into the diagram, then I have to connect to this Terraform module. This is like 2 lines of code to make in my code. Right now, I implement and support approximately like 70% of Terraform AWS modules which I maintain. And there are a lot of cool modules which I want to work with. I made these modules, but there are no connection on Cloudcraft side, like Transit Gateway, for example. It's complicated and it involves several accounts. It's cool to be able to do this. So I focus on something what's used by most of community members, which is EC2, Autoscaling Group, RDS. Believe me, but that's what 80% or 90% of people are using. If you ask people like, hey, what do you think about this recent service which AWS published, you will see just people don't understand what you're talking about. So yeah, there are possibilities to make things fast, but I want more involvement from the community who actually write this code, send pull request, and we merge it, and that's it. Then there will be support very fast.
Anyone else?
А я по-русски спрошу.
Okay.
Работает ли ваш модуль TF в обратную сторону или планируется ли так сделать?
Не, он не планируется. То есть он не работает, потому что он не планируется так работать. Потому что это на самом деле очень сложно сделать. И вообще все взаимодействие между модуль, ресурс и конечный ресурс в Амазоне, если посмотреть на эту всю связку, они очень сложные. Намного проще сделать, если у тебя есть TF-state файл, и из этого TF-state файла визуализировать это все в Cloudcraft. Это можно сделать, и я постараюсь сделать это примерно до ноября этого года. То есть Terraform state файл, и мы этот Terraform state файл визуализируем в виде какого-то рисунка. То есть такое со стороны Cloudcraft API есть, с моей стороны этого нету. Но я могу довольно легко конвертировать, потому что я использую, в общем, JSON репрезентация у меня в виде графа, и я граф сериализирую либо в одну сторону, либо в другую. Ну, в общем, реализация довольно простая, по крайней мере, базовые штуки. Если кто-то будет использовать какие-то либо странные сервисы, либо какие-то странные там связи, это будет очень сложно понять.
Еще тогда вопрос. А Cloudcraft не планирует перейти из 3D изометрической проекции в 2D?
Это вы имеете в виду
Рисунок.
вот эту кнопочку?
Именно ее. Потому что вы читали.
То есть эта кнопочка появилась, по-моему, около года назад. И тут еще есть такая штука 2D Export to Draw.io. То есть можно сюда экспортировать, дальше продолжать рисовать в Draw.io. А Draw.io — это бесплатная штука вообще, которую можно хостить самому. github.com/draw.io. И вот так вот выглядит моя инфраструктура. Довольно странно, по-моему. Ну, я не знаю, что он так выглядит. Я, наверное, выбрал тот один объект. Надо выбрать, чтобы ничего не было выбрано. Сейчас проверим. Да, вот. То у меня было выбрано один объект, поэтому оно показало так коряво. Ну, в общем, вот оно все. Преимущество вот этого всего, что это полностью бесплатная штука, которую можно хостить у себя в офисе за 10 фаерволами. Сложность, почему я не сделал из Draw.io в modules.tf, потому что формат, которым Draw.io оперирует, это кошмар. Это там что-то бинарное, в общем, ничего не понятно. Там бинарное плюс XML. Зачем, непонятно. Ну, зато бесплатная. Вот такой вот. То есть эта штука есть, работает. Было очень много людей, спрашивающих, мол, о, я не хочу пользоваться этим, потому что там 3D. И влепили такую фичу. В общем, она есть. Пользуйтесь на здоровье.
Последний вопрос тогда уже.
Есть ли у вас команда таких людей, которые работают в open source, помогает вам, и как к вам присоединиться, если есть?
Команда у нас такая, как бы понятие растяжимое на самом деле, потому что у нас есть слишком много желающих. У нас есть там 6 человек, ну, из которых реально работает, по-моему, 2, ну, я и вот этот товарищ из Франции. То есть мы вдвоем работаем. Он поддерживает EKS модуль, а я поддерживаю все остальные. В общем, то есть почему так получилось? Не потому что, ну, просто он захотел начать. У нас еще самое важное правило – это то, что ты хороший человек, классно все пишешь, все, мы с тобой согласны, все. Я не люблю подкидышей. И были некоторые случаи, вот, по-моему, вот этот RDS Aurora модуль, который человек пришел и говорит, вот я использую RDS, возьмите этот модуль. Но мы его взяли, все классно, и человек через неделю ушел, сказал, мне уже не интересно этим заниматься. Кто его теперь поддерживает? Правильно, я. И так возникало, ну еще с ALB тоже так появился, Customer Gateway, в общем, некоторые еще, Redshift, вот этот EBS. В общем, куча модулей, которые люди приходят, там, я тебе буду помогать. Я говорю, ну здорово, сколько ты будешь помогать? Да, вечно вообще все. Ну, в общем, вечность заканчивается примерно неделю. Я сейчас собираюсь, ну, как бы сейчас, не знаю, сегодня вряд ли уже, ну, надеюсь, где-то через месяц написать более понятно, более как-то попунктно, что значит сотрудничество. Я нашел такой интересный проект, называется, как он называется, даже не знаю, как он называется, Athens. И тут у них есть такая глава, как Participating in the Community, и тут расписано, кто что делает. Я думаю, может такое написать, и тогда люди будут меньше вопросов задавать и больше контроля. В любом случае, все, что я делал, оно и публично, и этот код, и вся инфраструктура по репозиториям, она вся open source. То есть как управлять GitHub репозиториями с помощью Terraform, это все open source. В общем, следите, и там будет еще кое-что интересное.
У нас
спасибо.
есть подарок за лучший вопрос. Осталось только его выбрать.
Ну вот человек узнал о том, что существует 2D View. По-моему, это... Ну... Все, спасибо.